Yes, sir, ladies and gentlemen. Back for another week. This week we got Lusak's law. Gay Lusak came up with a law that described the relationship between pressure and temperature. Something you all know. If you take a WD-40 can or a can of Axe, you throw it in the fire, right? That heat speeds up the molecules, they move faster, therefore your pressure increases. The number of collisions against the walls of that container increase as that heat goes up. Same thing, as the heat drops, energy, right, of those molecules decreases, so they slow down, coming closer together, okay? And that is represented in this formula right here. P1 T1 equals P2 T2, okay? See if I can change this a little bit. There we go. That might be a little easier to see. Okay. P1 over T1 equals P2 over T2. And again, the 1 and 2 subscripts, all they represent is the first set of conditions and the second set of conditions. So what I'm going to do here is, again, same way I've done it the last two laws, right, for Boyles and Charles. You don't have to do this, right? If you know how to do this and you're able to figure this out without writing this down, by all means do it. This is just a real way, since we're not in school, to keep your information organized. All right, so let's look at problem number one. I'm going to do two problems again. If you don't get it, I attached the same guy doing the same video, but this time for Charles' law as like another way you can check it out if you're still confused. So pressure of a propane gas tank is at 3 atm at 300 K. If the temperature rises to 330 Kelvin, what will the new pressure be in the tank? All right, so let's see. The pressure of the propane gas is 3 atm at 300 Kelvin. Okay, so pressure 1, 3 atm. Temperature 1, 300 Kelvin. What will the new pressure be? P2 is X. Temperature rises to 330 Kelvin. Now, since this is a direct relationship, that means as one goes up, the other goes up. As one goes down, the other goes down. So if I look here, my temperature goes from 300 to 330. So I know that my final answer needs to be greater than 3. Now, not a lot greater, because 300 to 330 isn't a really big increase. So if you had like 8, you're probably wrong. It's probably too high. All right, so let's plug these in. P1 is 3 over 300 equals X over 330. And just like with Charles' law, we cross multiply. So I'm going to multiply these two guys together, and I'm going to multiply those two guys together. 300 times X is 300X. Again, I like to keep the X on this side, regardless of what I'm solving for. Pressure or volume, or pressure or temperature, just because, again, mathematically, that's just more what we're used to. And then 3 times 330 is 990. Next step, divide both sides by 300. Okay, that cancels out. I'm left with X equals 3.3 atm. So P2, 3.3 atm. And if I look, right, 3 to 3.3, it's bigger, right? That 3.3 is bigger than my 3. It went up. All right. So second problem says, the pressure in a car's tire is 35 psi at 360 Kelvin. For the pressure to drop to 30 psi, what would the temperature have to decrease to? All right, this is a real life problem. Typical pressure in a car tire is 35 psi, right? In the winter, if you drive, you know you have to put air in your tires, because as the temperature decreases, the pressure goes down, so it drops, say, to 30 psi. What would the temperature have had to decrease to? All right, so let's fill it in. So car's tire is 35, pressure is psi, 360 Kelvin. Okay, what would the temperature have to decrease to? That's my X if pressure becomes 30 psi. So I know my pressure dropped, therefore my temperature's dropped. My temperature needs to be less than 360. Let's plug in 35. You know what, I'm going to make this a hair bigger here. So we've got 35 over 360. P1, T1. P2 comes up here, just like my formula says, right? 30 over x. Cross multiply, 35 times x gives me 35x. 360 times 30 gives me 10,800. All right, I'll get rid of that so I don't think it's a comma or a decimal. Okay, now divide, 35, cancels out, x equals, we get a big decimal here, 308.57, blah, 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 blah. All right, so let's see my final answer here. T2 is going to equal 308, and let's just round to the 10th there, 0.6 Kelvin. Started at 360, went down to 308, all right? And that's it. It's legitimately the same exact thing as Charles' law, except instead of volume, we're using pressure. So if you could do it last week, there's absolutely no reason you shouldn't be able to do it this week. And that is the end of the math for your gas laws unit. So no more videos like this coming your way. Sorry. All right. See you guys.